I'm continuing with my development of Thomases. This particular one has, sticking out of the funnel, a infrared detector. The sort of thing that you'd find on a television or DVD player or something like that, which receives signals from a controller like this. So now hopefully I can control my Thomas remotely. I've stuck a switch on the top, so switch it on, got a light at the front to show it's on. Put it on the track. Key 2 should send it forwards, and key 4 stop it. Key 3 send it back, key 4 forwards. So that is what I wanted to achieve, and I've managed to achieve it. So how have I done it? How have I managed to fit infrared onto Thomas? Well, essentially, let's have a look inside. I think we need to do to see what there is there. If I can undo the screw at the front, has that got it? Yes. When we open it up, I'm not using nickel metal hydride cells or alkaline cells, but a lithium cell to drive it. The lithium cell then is connected onto this circuit board here. So if I take the lithium cell out, should just unplug, shouldn't pull the wires, just unplugs, just a standard sort of lithium cell. It's supposed to have 400 milliamp hours, but I get 154, which is sort of typical for this sort of thing, but it's quite adequate for what I need. 154 milliamp hour means I can have 150 milliamps for an hour, and as this probably, I don't know, I can't remember what it takes, but it should give me quite a while with it. So that was the cell that I'm using to power it. I've got my wire coming down through the funnel, drilled down through the funnel, removed all the front of Thomas so that I could get to the funnel, and then just bolted him back again with this metal plate here across the front. I've also got my light, of course. This comes to the front, to the light, which just goes in where the light would have been on Thomas if he'd have had one, but the moulding's quite good, quite easy to get a 3mm LED in there, then bring the wires through back to the circuit board. I've left the resistor for the LED on the circuit board, so we can take that away, or we should be able to. That's just pinned in there, so we can disconnect that. And then we've got 3 wires coming from the detector on the funnel, which are then plugged into the circuit board as well. I didn't design this circuit board for Thomas, I designed it for a different application, but it seems it works for Thomas. I've put a bolt through from the back here to hold the circuit board in place, with a nut on the top there by the side of the switch. So the switch is there and the nut is there. If I take this nut off, hopefully Can't remember what's inside. I think that might just be going round and round. Nope, we've got him. There we have him. And the circuit board comes out. Still connected to the motor, so we'll disconnect the motor. Just have a quick look at this while we're here. I took away the top part of the motor, which holds the cells and has the switch on it, and replaced it with this plastic plate, and that then drives the pinion on the output shaft just as if it had done with the battery plate on the top of it. It has a nice little clicker on there, so that if somebody tries to turn the motor, then hopefully you can see the clicker opens and then it goes back again, so that the worm gear isn't damaged if somebody tries to turn the wheels. This plate isn't actually necessary because I have taken the battery holder and switch, cut them down, and they will replace this plate, which saves me a lot of work. So that's the base. I've had to grind away some of the bottom so that it'll actually run on the blue track, because the blue track is different to the track for this, which, if we can focus on it, it's I don't know what it is. Where is it? There. Made in China, 2013 Mattel is the one that I've modified. So let's look at the circuit board. Yeah, I build my own circuit boards. I've done it for a long time. I have a program which allows me to lay out the components individually, and not even lay out components, but put on, come here, come on, just put pads on if I need to. So for example, here I have a sort of layout, similar sort of layout. Here I have the pickaxe chip, here I have the motor driver chip. So here I didn't have the pin out for this, so I've just made this up. Then we've got the output pads. I can actually write on it when I've done it, and then infill it. Here's a picture of one just as I'm designing it, but it hasn't got the infill in. This one here has infill, so it doesn't use as much copper sulfate. No, not copper sulfate. What's it called? The stuff that I use it, ferric chloride is the stuff I use to etch my boards, so it doesn't use as much. This has been printed on overhead projector transparency using an inkjet printer. Seems to work well for me. I used to use a piece of paper and squirt it with WD-40, which made it transparent, but that needed about 11 minutes in the exposure unit as opposed to about 2 minutes using the transparency film. So that I can use the film efficiently, I cut down the piece that I need, a size a bit bigger than the piece I need, and print out on paper, and then I'd stick the clear film over the top of the paper, making sure I get it the right way round, because you can only print onto one side of this film, one side shining, the other side is quite rough. Then print them out, develop them, etch them, and come up with something like this. I tend to use 0.1mm spaced plugs and sockets, which seems to work well for me. I've put the switch, oops, oh, where did that go? Ah, there we are. Put the switch on, modified it. It's should have been over here, but saw it pop out the top of Thomas and moved it across. I'd have to design a new circuit board to put these switches on. Here we have a diode, surface mounted diode. Here, ooh, here we can see it, a small resistor, bit of insulating tape because of where that's put on. I don't want it to catch on anything. And here we have the output driver. Beautiful, these little chips, marvellous what they can do. Supposed, I understand, to be rated at is it a couple of amps anyway. Perhaps we ought to look at the data sheet. Here we are, data sheet. L9110. Perhaps we'll zoom in a bit. It's for 2.5 to 12 volts, so works for what I need it. Oh, it's only 800 milliamp continuous current output, but more than enough for my motors. So that's the surface mounted. Can get a dual inline package, but the surface mounted works for me. If we have a look at its circuit diagram, we have signals coming in, so two signals come in from the microprocessor and two negative or 0 volts on this side, 2 positive volts on this side, and then it just goes out to the motor. They suggest a 10 and a 0.1 microfarad capacitor just to smooth out the supply. Beautiful little chip. So how have I used it? Well, let's have a look, see if we can find a circuit diagram. This looks like a circuit diagram. Pickaxe chip here, the 08M. Got the infrared in here. The power comes in through a 0.1 socket, through a diode to the switch. Always put a diode on because always I seem to be able to connect things the wrong way round despite lots of colour. Then goes into the L9110 straight away and into a capacitor across the supply. Round and into a diode that then feeds the 08M just to try and isolate it from any back EMF from the motor or any spurious pulses on the supply lines. That then feeds the opto, the infrared detector, via a resistor with a little capacitor between 0 volts and positive. The output from the detector goes straight to pin 3 and is pulled high by a resistor here. The 08M has quite, well, it's 1, 2, 3, 4, 5 outputs or inputs, but I'm only using, now I've got to be careful here, output 0, which is also used for the programmer, and that then goes to my L9110, and I'm also using pin 1 to go to the 9110. Anybody who's astute out there will say, well, that's not pin 1 and that's so for the chip I tend to use the leg, call the things on the chip, the physical things on the chip, the legs, and the software outputs the pins. So this is leg 1, leg 2, leg 3, leg 4, leg 5, leg 6, leg 7, leg 8. But this is actually pin 0 when it comes to programming. Quite complex. So how do we program it? Well, the Pickaxe range of chips has a very clever, I think, programming editor. I'm using the older version because the later versions, well, I'd have to learn how to use them, so I use the older version. And all we have to do, I've got a bit of gubbins here that I don't need. The main program then, all we do is use the command infra in, and that means that the pickaxe chip will wait here until it receives an infrared signal or an infrared input. Then I look at the infrared input. Was it number 19? If it was, then go to forward 1. If it was number 18, then go to backward 1. And if it was 16, then stop. So these are procedures, well, these are little programs down here. So forward 1 just goes, sends output 1 high and output 0 low, thus sending the motor forward. The opposite then for back, and then it just goes back to the main and waits for the next signal. Backwards similar, sends output 1 low and output 0 high, so it's the opposite of that one, and then goes back to the main, so it sends it backward. And stop just sets both outputs low, and that stops it. So that's all it really needs for this program. Very simple, very straightforward. There's lots of other stuff on here because I was trying to do 2 motors with it, so that's why I've got the extra program. But basically all we need is this infra in, 3 lines to detect which button's being pressed, and then 3 little, are they procedures or just routines or whatever you want to call them, just to send it back. So it's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines just to be able to program it. I like it. I like pickaxe chips. You've also got a sort of simulation on here so we can simulate what's happening and look at the variables that the chip is actually using. Although on this particular one I'm not even bothering with variables. Although up here, for example, simple pulse width equals W5 means that W5, the variable, the word as it is called pulse width, and W6 is loop count, but I'm not using those at the moment. Yep, it's brilliant. It's pickaxe. I've used it for a large number of years, but they're moving on, and unfortunately their chips are getting a bit expensive for me when I can buy an Arduino for not much board, for not much more than a single 08M pickaxe chip. But I've got a few left over from history, so I might as well use them. So that then, an infrared controlled Thomas using a pickaxe 08M chip. Pretty chuffed with that, really. Like what I've managed to achieve. So now I can move on and see what else I can do using the infrared. So it's bye now. Bye.